Hello together. This is a more detailed video concerning the commissioning of our CPX-AP-I Ethernet IP node with guard logics and the generic EDS. What you're seeing here, my system here in the logic software is running already. Also my node has an IP address received, which is 192.168.0.5. To start the commissioning, I'm just going here offline. Make here a right click, new module, and I'm using now a generic one, which I'm finding here from the vendor Rockwell Automation. This is a generic Ethernet module, and if I make a double click, then it is appearing here as pop-up. First, I have to define the name, my API, then the IP address 192.168.0.5. And now here is the communication format. You see here we have different possibilities of the communication format. And depending on your choice, the connection parameters and the assembly instances are changing. If we have now a closer look in the support portal, then we are seeing here an application node. I strongly recommend to have a closer look in the application node to understand all the details of the assembly instances. In the application node, you see here an explanation of the possible assembly instances at our CPX-AP-I Ethernet IP node. You see here the communication format, SINT, int, double integer. And here you are seeing the instances. And depending on your choice here, you can use the assembly instances from the node. For example, if I'm now doing here data SINT with status, then I have here the input assembly instance, the output assembly instance, configuration, status input, status output. Going back to the node, I have just to look for the format. Means input would be, for example, possible 100, or for example here with fixed input size 134, or here 110 with fixed input data size. Every time if you are choosing a fixed input data size, then you are telling the system, okay, we are allocating just the amount of bytes depending on the instance. For example, here 110 would mean we are allocating 60 bytes. We don't care how the system of API is looking, we just use the first 60 bytes. For this video, we are using now, for example, the 100, the 101, and because we have chosen diagnostic, the 131. All three are in SINT format. We have here 100, here 101. The configuration is default always 102. The status input is 131, and the status output is defined by Rockwell with 254. Now here the size. Here we have now to define the size. We have taken the exact input size. That means we have now to define the exact amount of processed data in our API system. The easiest way is, if we have an online access, going to the web server of the API system, and here at Ethernet IP assembly view, you are finding all the possible instances. And you see here 100 at the moment allocates 30 bytes, 101 allocates 28 bytes, and the 131 allocates 42 bytes. With this kind of information, I can go back here and say here, this is 30, this is 28, this is 0, this is 42. Okay, and then I'm downloading everything. But you are now recognizing the system is running. I have no error, means everything what we have done is correctly. And in the controller text area, I have now all my tags available. Here are the input tags. Here are the output tags. Here is the status information, at the moment 0. But if I provoke an error, for example, just disconnecting the communication cable is an error, then I'm getting the message here inside my status. And if I'm looking in the API Ethernet IP menu, I can decode it and know exactly what was going on. I connect now the cable again, make a power off on of the system, and everything is green again. And the last step, what I want to show you here in the video, is here the output size for writing process data. You see here we have 28 cents. And which one belongs to which module? This is a good question. And therefore, I again strongly recommend go to the assembly view, have a look on the output exact synth size. And if you scroll down here, then you are seeing all the modules and the offset. And for example, here 216 would be our module number 6, the 4 digital input and 4 digital output module. And 216 is nothing else as 216 divided by 8, address 27. Going here down, address 27, making here a 1. And here you're recognizing I have done no mistake. Address 27 has switched on the output. Here, the last module is an analog input module, has no output address area. That's the reason why it is not appearing in the output size in the configuration text. I hope this video helps you. It has a lot more details if you're using generic EDS. And thanks for your attention and have a nice day.